Hello everyone, this is Abhignya from CSCA. Now I'm here to give a presentation on permutations and combinations without replacement. Now let us discuss what we are going to learn from this presentation. Here we're gonna discuss about permutations and types of permutations, combinations and types of combinations, difference between permutation and combination and its application. Now, let us start with the fundamental principle of counting. It is nothing but suppose let us say an event A which can occur in m different ways, and another event B can occur in m different ways. Then the total number of events could be m into n ways. Let us understand it by with an example. Let us say a person named Rohan has three shirts and two pants. In how many ways combinations are possible? Uh, Here we can select. Selection can be performed for three shirts. That is, selecting shirts can be performed in three different ways. And selecting pant can be performed in three different ways. Sorry, in two different ways. We have two pants. So the total number of combinations could be 3 into 2, that is 6 from fundamental principle of counting. So now let us discuss what is permutation. A permutation is an arrangement of objects in specific order which are used to calculate the number of possible outcomes when order matters. Permutation is an ordered combination. Now let us discuss types of permutations. We have three different types of permutations. That is permutation of n different objects. That is permutation without replacement. Permutation with repetition. That is permutation with replacement. And permutation when the objects are not distinct. So let us discuss these three types of permutation in coming slides. Now, permutations of n different objects, that is permutation without replacement. What is it? Permutation without replacement refers to arrangement of objects in specific order without allowing repetition. That means here we restrict the repetitions. We won't allow it. Once an object is used, it cannot be reused in the same arrangement. In such type of cases, we can directly use the formula NPR, that is n factorial by n minus r factorial. Now let us solve an example on this. Uh, Let us say we want to find the number of ways of arranging three-letter words from the letters A, B, C, D, E without repetitions. So here the total number of letters available Here the total number of letters available are A, B, C, D, E, that is 5, and the total number of letters in each word should be 3, that is, so our R is 3. So we need to find the total number of possible words could be 5p3 directly. We can use the formula in this case, that is 5 factorial by 5 minus 3 factorial into 5 minus 3 factorial. Right. And that could be 5 factorial by 2 factorial, that is 60. Let us discuss another example on this topic. So here, what could be the order of 16 pool balls be in? That means we are given with a 16 balls. Each ball is labeled with some number like 1 to 16. So our first choice in this case will have 16 possibilities. Our next choice could be 15. Uh, we have That means we have to pick, in first case we have to pick from 16 balls, and then our next would be one ball is already we have fixed it, and next we have left out with 15 balls, so we have 15 possibilities. Like that, total permutation could be some big number. So let us take some small problem in order to going that much complex. So here we need to choose just three of them. We do so what we will do, uh, our first choice could be 16, followed by next choice is 15, and next could be 14. That is 16 into 15 into 14, that is 3360. So one point to be noted here is we have to reduce the number of available choices each time we are reducing here. That is a point to be noted. Let us move into the next slide. Permutation with replacement or permutation with repetitions. Here it is also similar to the permutation, but the only difference we had is, we can use we can select multiple times. We can select the element multiple times. In such cases we can directly use n power r. The permutations when where r things from n things have to be arranged with repetition is just n power r. We can directly use the formula n power r. Let us see an example. Now we have three letter. Now we need to find the three-letter word that can be formed from the letters A, B, C, D, E, in which the letters are allowed to be repeated. The number of available letters are 5, that is A, B, C, D, and E. The number of letters in each word is 3. R is 3. So we can directly use the formula n power r, that is 5 cube, that is 125. Now let us discuss permutations when the objects are not distinct. If all n things are not different, say among n things, S1 objects are one type, S2 belongs to second type, and Sn belongs to nth type, then the number of possible arrangements could be n factorial by S1 factorial into S2 factorial and so on up to Sn factorial. Let us solve an example. Here, find the number of arrangements of the letters of the word Peter. So, the total number of letters in the given word is 5. So, in Peter, E is repeated 2 times. So, the number of and P is repeated one time, T is repeated one time, and R is repeated one time. So the number of possible arrangements could be 5 factorial by 2 factorial into 1 factorial into 1 factorial into 1 factorial. That is 120 by 2, that is 60. Now let us discuss about combinations. What is combination? It is a fundamental concept in the combinatories. It is a fundamental concept in it's a fundamental concept in combinatorics that allows us to uh, to calculate the number of ways to select a particular subset of items from a large set where order does not matters. Here it is we can calculate the number of combinations by using NCR, that is n factorial by n minus r factorial into r factorial, where n is the total number of items in that set and r is the number of items to be selected. Now let us move to the next slide. Combination without repetition. Suppose combination without repetition means combination without replacement. It involves selecting items from the set where each item can be chosen only once. Here the order matters. Sorry, here the order doesn't matter. It means that same object selected in different orders, it cannot be taken. It cannot be regarded as the same combination. Here we have two important rules. for selecting an object, that is order of selection does not matter, and each object can be selected only once. Means once item is selected, it cannot be chosen again. It is a simple combination. Here the formula we use is NCR, that is n factorial by n minus r factorial into r factorial. Now let us solve an example on this concept. Consider a set E. A set A have consisting elements A, B, C, D, E, 5 elements. The number of possible combinations of 3 elements could be uh, from this set A could be. So here the total number of items are 5, that is n is 5, and we have to take 3 at a time. From the formula we can say that 5c3, that is 5 factorial by 5 minus 2, that is 2, 2 factorial into r factorial, that is 3 factorial. So that at last we gonna get as 10 combinations that are ABC, ABD, ABE. If you observe here, uh, no combination is repeated. No combination is repeated. Now let us move to the next slide. Combination without replacement. Sorry, it's combinations with replacement, that is combination with repetition. It means that uh, it is similar to combination, but the only thing is we can choose item multiple times. That means combination with replacement refer to the selection of items from the set allowing the same item to be chosen multiple times. Here we can denote it as n plus k minus 1. N choose k with replacement. We can, the formula is n plus k minus 1 factorial by k factorial into n minus 1 factorial. Let us solve an example. Suppose you have three colors, red, green, and blue in a set, and you want to choose two colors with replacement. The number of choices we have to make is 2. The total number of colors we have here is 3. That is, n is 3, Rn is 3, and r is k is 2. So from the formula we can we want to find C4 of 4 comma 2, that is 4 factorial by 4 minus 2 factorial into 2 factorial, that is 244. Here we will get 6 combinations, that is red red. We can get two colors, we can take two colors at a time, two similar colors at a time, and red green, red blue, and so on. Like that we'll get 6 combinations. Now, let us discuss differences between permutations and combinations. In permutation, order does matter. Permutation is an arrangement. It involves two steps, selecting and arranging. Here, order matters. For example, 472, uh, let us take a log code as 472. In place of 472, if we take it as 272, it won't open. This is a simple example of permutation. And whereas combination, here order doesn't matter. Suppose we have a fruit salad. Let us take apple, grapes, and bananas. In that, if you take apples, bananas, and oranges, same output will be there, and bananas, grapes, and apples also same, in irrespective of which order you take, same output you will get. Now let us discuss about combination is about selecting the elements from the set or a collection. Now let us sum up what we have discussed till now. So when repetitions are allowed, in permutations, we use the formula n power r. When there is no repetition, we use n factorial by n minus r factorial. Uh, for combinations, we use these formulas and so on. I hope with the image 2 you are clear about the differences between permutations and combinations. In combinations, AB is equal to BA. If AB is present, we cannot take BA. But whereas in permutation, AB and BA both are acceptable. Uh, And one other important point to be noted is permutation involves two steps, selection and arrangement, whereas combinations involve only selection. Now let us discuss some applications of permutations and combinations. We generally use permutations in setting. This is a sorry this is an application is an application of permutations. We usually use this as a code or lock, and picking a captain or short stop from a group, arranging people, digits, numbers, alphabets, letters, and colors. In such cases, we will be using permutations, and combinations we will be using to count the number of possible combinations when we are going to order food from the menu. Selection of menu, food, cloth, subjects, theme comes under combination. I hope you have learned something new from this presentation. Thank you.